much for that introduction. And a lot of the people who have been presenting are generating data and or analyzing it. We're doing something else. We are trying to lower the barrier to reusing data. And I'm sure I don't need to convince this audience why it would be good to do that. But as you also probably know, it's not easy to reuse most data sets that you find for various reasons: the use of ad hoc formats and data structures, the lack of compliance with FAIR guidelines. Many of the data sets you find are not annotated with standard ontologies. There's a lack of mapping of identifiers to other data. And a lot of data is locked up in text formats, for example, publications, or it's in spreadsheets, but without metadata accompanying it to constrain or describe the data sets. So we came up with LinkML modeling language and toolkit. The goals are to make biomedical data more fair, to make implicit models explicit. It integrates ontologies and semantic web standards and creates shareable, reusable models of data. So at its heart, LinkML provides a metadata model for structuring your data, where each model consists of a schema that's divided into a set of hierarchical classes, each of which have attributes or slots that describe them. And because there are many different types of people who generate and work with data, we provide multiple ways in our toolkit to author LinkML models. So for example, if you're comfortable working with spreadsheets, LinkML has tools called Schema Sheets and Schema Automator that will help you make that spreadsheet into a schema. And you can also start a new schema from scratch using our project cookie cutter. And LinkML can then auto-generate many kinds of data models. It has a LinkML YAML format. There's a little sample of that on my slide. But it also is conversant in many other popular formats that are used to share data, including OWL, Shex and Shackle, JSON. It can also output Python and Java, SQL, and another thing it does is generate searchable documentation. A growing number of projects are using LinkML to model their data. Some of these are also partly NIH funded. So with the funding that we received, we're hopefully helping other NIH fundees share their data in a more reusable and fair way. We have many contributors to this work beyond our core team. We have a lot of people from the community getting involved and contributing to our open source code base. We also have an open issue tracker where people can file bugs or make suggestions. We hold a monthly community meeting, which features someone from an external project speaking about how they used LinkML to help them in their research. And you can find all of this from our LinkML documentation website. You can take a picture of that QR code there. And finally, just wanted to thank the NIH for helping to fund this research. Thanks.
We do have time for a question, if anyone have one.
Yes. Oh, sorry. Making space for others. Where do you folks see this being used? If I'm sort of a traditional researcher answering a biological question, do I bring this in during experimental design? Do I bring it in once I'm collecting data? Do I bring it in once I've done a really good job and have well-formatted data, and now I turn it into this?
Yeah, that's a really good question. And I would say the earlier the better, because we are providing tools that if you already collected the data in a spreadsheet, you can now sort of retroactively impose some structure on it. But I think that if you apply these tools earlier in the process, it will only make things easier for you as you collect data and make it reusable by others. Thanks for asking.